Welcome back to the Smart Video Lab. This video is going to focus specifically on point-slope form of a linear function. So to this point, we know several ways to write a linear function. We've got explicit function rules, and we've got now-next rules. So the last video looked at the explicit rule, y equals mx plus b, for a linear function, and that's called slope-intercept form. Now this video is going to focus on another way of writing an explicit rule for a linear function called point-slope form. Y minus y1 equals m times x minus x1. That is point-slope form. So now, going over here, looking at point-slope form, again, we just said that's y minus y1 equals m times x minus x1. So point-slope form is useful when you're given a point and a slope. So let's say the slope is 4, the y-intercept, nope, we don't want a y-intercept this time, we want a point. And the point is 3, 2. This point is points are always x, y, so this is going to be our x1, y1. So it's going to be y minus 2 equals the slope, which is 4. So that slope is going in for m, times x minus x1, which is 3. So that goes in there. So that would be point-slope form of that linear function. Now I could convert that if I solve for y. So this is point-slope form. I could easily convert that to slope-intercept by solving for y. So I could distribute y minus 2 equals 4x minus 12. Add 2 to both sides. Y equals 4x minus 10. That would be slope-intercept form of the exact same function. So both forms represent the same function, but it's just a different way of representing it, and each has its uses. So now let's look at a couple of examples. Let's say example 1, what is the function rule in point-slope form for a linear function with a slope of negative 3/4 that passes through the point 1, 2. So we want point-slope form, which we just said is y minus y1 equals m times x minus x1, and you really just want to memorize that. The slope is 3/4, negative 3/4, and it passes through this point 1, 2, so that's x1, y1. So to write the function rule, that'll be y minus, actually, pause the video for a second, try to write the rule yourself, and then play to get the answer. So the answer is y minus 2 equals the slope, which is negative 3/4, times x minus x1, which is 1. Example 2. What is the function rule in point-slope form for a linear function with a slope of 5 that passes through the point negative 1, 2? Pause the video and try it yourself, and then play again to see the answer. So again, we want point-slope form. Y minus y1 equals m times x minus x1, with a slope of 5 passes through the point negative 1, 2. So that's going to be y minus 2 equals slope, which is 5, times x minus negative 1. Remember, minus negative 1 becomes plus, so that's y minus 2 equals 5 times x plus 1. That would be the best way to write that linear function in point-slope form. Looking down now to example 3. What is the function rule in point-slope form for a linear function with a slope of 5 that passes through the point 3, negative 4? Pause the video, try that one on your own. So the answer, again, we're going to use the same form, y minus y1 equals m times x minus x1. So it's going to be y minus negative 4 equals the slope, which is 5, times x minus 3, because this was our x1, y1, and this was our slope. So I could write that as y plus 4, and I should write that as y plus 4 equals 5 times x minus 3. And there we have it. So another type of example where you want to use point slope form is when you're given 2 points and asked to write a linear function rule. Sorry for the interruption. My mom just came over. Alright, so anyways, example 4, we want to write a linear function rule in point slope form of the line that passes through the points -2, 4, and 4, -5. Even if you weren't told to write it in point slope form, you would want to start there. So we're going to use, because you're given 2 points, we're going to use y minus y1 equals m times x minus x1. So for point slope form, we need a point. We have 2 that we can pick from. We also need a slope. We don't have a slope yet. So remember, slope between 2 points, slope is always change in y over change in x. But when we're given 2 points, that looks like y2 minus y1 over x2 minus x1. So let's call this x1, y1, because points are always x comma y, and x2, y2. So the slope in this case is going to be -5 minus 4 divided by 4 minus -2. So that's -5 minus 4 divided by 4 plus 2, which is -9 over 6, which simplifies to -3/2. So now I have a slope, and I can pick a point. I'm going to pick this point first, and I can write the rule as y minus y1, y minus 4 equals -3/2, the slope, times x minus -2, which again becomes plus 2. So I could have also chosen the other point, and the rule would have looked this way. It would be y minus -5, which becomes y plus 5, equals the slope, -3/2, times x minus 4. And if you solved each of these function rules for y to get in slope-intercept form, you would see that they're exactly the same. So here's another example. Write a linear function rule in point slope form of a line that passes through the points 3, 10, and 5, -4. Actually, before we do this one, I want to go back to the other one for just a second. Let's say that from this point, you were told to, once you got these function rules, you were told to now write the rule in slope-intercept form. And that's what you'd have to do if you wanted to graph it. So to do that, we would just need to solve for y in each rule. So I'm going to take this rule, y minus 4 equals -3/2 times x plus 2. I'm going to solve for y. So that'd be y minus 4 equals -3/2 x. -3/2 times 2 is like -3 times 2, which is 6, divided by 2, -6 over 2 minus 3. And then I'm going to add 4 to both sides, and I'll get y equals -3/2 x plus 1, because -3 plus 4 is 1. So the slope, again, it's clear as -3/2. The y-intercept of this function rule, we could tell now, is 1. Now let's suppose we wanted to do the same thing for the other rule that we wrote. Y plus 5 equals -3/2 times x minus 4. Again, we said we should get the same thing, so let's see. If I distribute, I'll get y plus 5 equals -3/2 x. -3 times -4 is 12, divided by 2, that's 6. Subtract 5 from both sides, and voila, I get y equals -3/2 x plus 1. So as promised, these are exactly the same, because these two function rules are equivalent, they just use different points. So the moral of the story is, if you want to write a function rule in point slope form, you could have picked either of these two, and we could have stopped there based on this question, but we looked at a little extension, which was this question, writing the rule in slope-intercept form, to see that if we convert our point-slope forms to slope-intercept, they do in fact represent the exact same line, which is our goal, because we were asked to write a linear function rule of the line. We're only looking at one line in this whole example, just 3 different ways of representing one line. There's one way, another way, all valid ways of representing that line. So now we want to write a linear function rule in point-slope form of the line that passes through 3, 10, and 5, -4. So this is the exact same as what we just did in the beginning of this example when we stopped here. So pause the video and try this one on your own, and then replay the video to see if you got it right. So again, point-slope form, this would be y minus y1 equals m times x minus x1. We don't have a slope yet, so we have to find it. So the slope, which is m, is going to be y2 minus y1 over x2 minus x1. There's x1, y1, x2, y2. So that's -4 minus 10 divided by 5 minus 3. -14 over 2, which is -7. That's my slope. So I'm going to pick this point because it's easy. Write the rule, y minus y1, y minus 10 equals -7 times x minus 3. Because -7 is our slope and 3 is our x1. Or you could have written the rule using this other point, and it would be y plus 4 equals -7 times x minus 3. So now let's say we want to graph this function. That means I need to convert to slope-intercept form. So this is point-slope form. We want to go to slope-intercept, which means solving for y. So that's going to be y minus 10. I'm going to distribute -7x plus 21. Add 10 to both sides. Add 10 to both sides, and I'll get y equals -7x plus 31. Now graphing this is going to be a little bit tricky. I'm just going to have to pick an appropriate scale for the graph. So since my slope is 7, I'm going to go by 7s on the y-axis. And if our numbers were smaller, our y-intercept was smaller, and our slope was smaller, it'd be easy because we wouldn't have to change the scale. But as it is, we can do it. And I'm going to leave my x scale as 1s. So the y-intercept, we begin at 31, which I can't see exactly, but I'll approximate that. It's about here. And remember, each box represents 7 in vertical change because of the scale that we chose. So my slope is -7, which means -7 over 1. So my rise is 7, run is 1. So I'm just going to go down 1 entire box length. And over 1, down 1 entire box length over 1, because each box length represents 7. And I'll repeat that process. Ready to graph my line? There we go. Alright, thank you for watching this video. If you did, write NC State on the top of your test and get +3 points on your test. You guys are champions.